So it says Malcolm plants a vegetable garden in the spring, and the number of plants that grow is 4 less than the number of seeds. So let me think about that. We have seeds, and how do I say 4 less than seeds?
S minus 4.
It might be S minus 4. Now I could be wrong, I'm just guessing. So we're saying the number of plants that grow is 4 less than the number of seeds. The table lists the number of seeds planted. So my plants is equal to 4 less than the number of seeds. So I think we might be onto something. Let's find out. So what's 15 minus 4?
That's 11.
So in other words, the number of plants is equal to 15, because this is like saying S equals 15 minus 4, which equals 11. Let's try that again. S equals 20, so then P of 20, really we should use function notation if it's a function, minus 4 equals,
16.
I forgot my, yeah, I said function notation, then I just did the problem. We'll do function notation on the next one. So I got 16. Now, let's do the last one. What's 25 minus 4?
21.
21. Now remember, if this is a mathematical relationship, there should be a pattern. So one way I could double check the pattern is, what's the difference between 16 and 21?
5.
Positive 5. 11 and 16.
5.
6 to 11. 1 to 6.
5.
So we're probably right in our math. We're working a little backwards. Before we looked at the pattern, then we tried to guess the rule. Now we're guessing the rule, and we kind of are looking at the pattern to see. Now what am I doing with this x?
You're adding 5.
Plus 5, all right. And from here to here?
5.
Add 5. So what do you think this number would be?
10.
How'd you get that?
Because 10 is super 5.
15 minus 5, right? What's the next one?
5.
Yep, I'm going to get there. So one of my students said, well, you could just add 4 to this number. In other words, if we said P is equal to S minus 4, and we're given P, in other words, you could say 6 equals S minus 4, and then you would add 4 to both sides, and that's how you would get that S is equal to 10. Does that make sense? Because these would cancel?
Yes.
All right, good. So now let's write the points out. I've got 5, 1, 10, 6, 15, 11, 20, 16, and 25, 21. All right, not too shabby. So now what's the next step? What do we got to do next? We got to plug it, we got to graph it, right? So 5, 1, remember this is my x coordinate, this is my y coordinate. It's a funny looking y. Okay, and let's zoom in a little bit so we can see how awesome we are at graphing. So I'm going to go 5 units to the right, because this is a positive 5. Remember that it's x, y from the origin. So I'm going to go over to 5. We're counting by 4, but really we're counting by 2s, right? So that would be like 6, and this would be like 2. So 5 is probably right here. 5, 1 would probably be about right here. Okay? So now the next one would be 10, 6. So if I go to 10, which is right here, and I go up to 6, this is 6. So let me make my dots a little bigger. This is like 10, 6. This is 5, 1. The next one's going to be 15, which I'm going to go, this would be 14. 15 will be right here in the middle up to 11, which would be about right here, roughly. So that's, and I'm going to write it on this side, 15, 11. Then what's the next number I want to graph? 20, 16, and I have points for that, so that'll go right there. Okay, and then what's the next number I need? 25, which would be right here, and then 21, which would be about right here. So, an interesting thing there is, what do you notice?
It's the
It's a
same
straight
rate of increase.
line.
It's a straight line, which is true, but there's a
It's not easy.
It's a constant rate of increase.
it's a constant rate of increase. Good. Wow, that's a very formal definition that I was looking for. But you could say that the slope is equal to 1, so it's linear, is another thing too. So remember, over here, my delta x was equal to positive 5, right? Or I'll just write it on this side of the paper. My delta x was equal to a positive 5. In other words, when I looked at my table of values, we just kept adding 5 to get from one value to the next. My delta y was what? The change in y was what? 5. So now my slope is equal to the change in y over the change in x. So as my student eloquently put it, he said that it's a constant rate of change, which is the slope, which is 5 over 5, which means the slope is equal to 1. In other words, I went up 1 over 1, up 1 over 1, and it connected the dots. So because I know mathematically by the graph and by my table of values that my slope is 1, I'm just going to take a ruler, because it's a linear function, and just draw a straight line. Does that make sense? And then my dots are off a little bit, so I'll just make bigger dots. But because I know the number of values are correct, I feel confident about the way that I've represented this. Any questions?